environmental film tonight, which is about water policy, how to manage a river that's shared by conflicting user groups. This is a very common advanced placement exam topic. And I gotta tell you, every year I make my top 10 most likely exam questions. I'm fairly confident that one of the most likely this year would be water allocation and river management, which is the topic of tonight's movie. I have a hunch that this movie would be helpful on the AP test. It's also a very relaxed, easy to watch, not super bad news movie. It's kind of like a human story about different people on different sides of the debate. If you're interested in politics, I think it might be interesting to you. It's called Riverways at 6 p.m. in this room. And there's a trailer for it available on the Facebook for this class. So, I don't know if it was my fault or Julia McClintock's, but somehow we've lost our packets for the field trip. Just so you know, the field trip is next Monday. It's a very good field trip. This one, usually I get very few complaints. Students usually speak very highly of it. We basically walk into the creek at 4 different parks. So we go to Schofield Park at the base of Rattlesnake Trail. Then we go to Rocky Nook Park by the Natural History Museum, Oak Park, down by the freeway. We go into the gutter where people skate down by the hospital. And then we take our lunch down by the grassy spot next to the pier. If there's enough time, we can go swim down there. After that lunch, we go to the wastewater treatment facility, which does smell like poo, but it's also really interesting and kind of cool, and they talk about it a lot on the AP test, so I think it's a really worthy curricular field trip. It's also really nice because we're chilling in the creek half the day. It's all bus supported with very little walking. It's a super classic, really nice field trip next Monday. Just so you know, the one problem is you'll get the packet tomorrow. Touch your nose if you heard that. And it's due on Friday. So you'll have a 24-hour window for the packet.
What time do we get back?
Beginning of period 6. Around 2 o'clock.
We have to go to OSC?
You're not excused for it. My period 6 is just going to sit here with the sub. So okay. If there are no other questions about the field trip, we're going to skip dams for now. We were building a dam the last time we did lectures, but we need to talk about the content of the field trip. We'll get to dams next week. By the way, how many of you have Mr. Forster for your English teacher? Did you guys have to do an English assignment about dams? Yeah. Overall good idea, overall bad idea to have the same reading for his class as mine?
Bad idea.
We did it all last week.
We had to read the packet a week before we...
No, it was fine. Just the dates of reading were off. He wanted us to read it last week, and he wanted it read this week. So we worked on that.
So the only problem was that just the timing was bad of his assignment relative to the timing of my assignment. Got it.
See, it was so much easier to explain to you than it was to him.
Well, he said he talked to you.
He did talk to me.
And how you were going to read all of our writing.
Yeah, I didn't actually sign up for that.
Yeah.
I don't.
We were like, Mr. Forrester, he's not going to read it.
You didn't volunteer.
Picture, like,
You're trying to sell
solely
that,
for
and
it.
he's gonna bring like a stack,
Like this.
foot
thing.
high.
For you.
Of all of our cootie papers.
Said we had to bring it.
He says he also has to write a report on issue. I'm just kidding. What?
I think it's really cool that we cut down on the reading that you do that's disparate, and I think it's a really good concept to have the reading for one class overlap with the reading for another. I'm sorry that the timing didn't work out better. So now, we need to do study goal number 24, which is about channelization. Then we'll do number 26, which is that stuff. And then we'll do number 28, which is this stuff. Okay. About number 24. The word is channelization. And how many of you have seen the Los Angeles River? So check it out. For those of you who've never seen it, when you hear the word river, you probably don't think of that. But for most of the Los Angeles River, it looks something like this.
Then,
Nobody likes flooding.
wait a second.
Historically, if you lived near a river and it rained, your house would become a wetland. Nobody likes it when their house is a wetland. Nobody likes it when their preschooler goes bobbing away in the mudslide. Nobody likes it when the house is flooded and the drywall gets moldy and you lose your family heirloom furniture or whatever. Flooding is a downer. Take it from me. I grew up in a part of the country where we had gnarly flooding. We didn't have a lot of family heirloom stuff because of all the flooding. And in many parts of the modern world, flooding is a thing of the past. I don't want to make any assumptions, but my hunch is that your family heirlooms have probably not been threatened by flooding. Probably. This is especially important in a place like Santa Barbara because most of Santa Barbara is just barely above sea level. If you go to the funk zone, that water has to travel like 1 to 3 miles to drop like 4 inches. That's massive flooding. It's pretty much sea level. And so in a place like Santa Barbara, which historically was all wetlands, we did a bunch of this. You take the old creek, you turn it into a concrete gutter, and when it rains, the water goes flushing out of town. You get rid of the water. It is a significant societal benefit, a success of engineering, thank goodness, that the water is not piling up in front of your house or inside your house or at your little sister's preschool. But I want to talk about the comparison because natural rivers are kind of cool. So here's what I'd like you to do. Write down physical environment, ecological relationships, and human benefit. Physical environment, ecological relationships, and human benefit. And then we're going to list those for a natural river and compare them with a canal. So, in a river, the physical environment has, number one, habitat diversity. I know that a lot of you don't care about rivers or have never seen a river or don't ever want to see a river. But if you have any experience with rivers, you know what I'm talking about. They have a diversity of habitats. If you've been to a river, you know what I'm talking about. There are steep, rapid, whitewater, foaming, heavy waters. And then there are slow, meandering, sandy gravel beds. And there are deep pools and riffles and waterfalls, some white water, some babbling brooks. So that habitat diversity is really important in a real river. Number two, there's what we call riparian vegetation. You know, river plants. So stuff in the water, along the banks, up on shore, big trees. And that riparian vegetation is a big deal. Number three, because of all the shade, you get consistent temperatures. The river stays nice and cool. And number four, all of that tumbling water and the shade and the low temperatures means you get high levels of dissolved oxygen. This is a real river. Habitat diversity, riparian vegetation, consistent temperature, and high dissolved oxygen. Yeah?
What's the positive high dissolved oxygen?
Well, fish breathe. Now, ecologically, that does a lot too. Now, the ecological benefits are, number one, you get a complex aquatic food web. You know, there's decomposers, there's insects, so you get what's called the nursery effect for fishies and amphibians.
What is the nursery effect?
Safe place for making babies. You know, like a nursery. So you get a nice place for the birds to come and eat. You get a nice place for the grizzly bear to come eat fishies. Does Jacqueline assault all of her teachers with yawning, or is it just me? Is this just the one time of day? Is it personal?
No.
Is it me? Do I need to dance more? Is it my voice? Does it put you to sleep? Because you make me yawn. And the whole class starts yawning. And I literally lose like 10 minutes a day yawning because of you. I'd like you to wear a paper bag.
I am not saying
Please. Yeah. Now, humans benefit from everything I've just said. For one thing, all that biological activity means bioremediation. Rivers eat our pollution. Bioremedy. All that food web, that gets rid of our trash. Not everything, you know, it's not going to get rid of like uranium. It's not going to get rid of like plastic bottles. But it'll get rid of organic compounds, it'll get rid of biodegradable materials, it'll soak up and break down a lot of the chemicals in our runoff, eat up like dead leaves and grass clippings and paper shavings, I don't know. Another way that humans benefit is real rivers are critical groundwater recharge areas. We make more groundwater when we have rivers. And of course, I know some of you couldn't care less, but real rivers are nice. They're a good place to go recreate. You can go kayak, you can go fish, you can go frolic with your loved ones. Experience the romance, hide in the shade. This is what happens when I get sleepy. Compare that to a canal, because a canal, number one, has no habitat diversity. A canal is just a concrete gutter. It's just a, you saw the last picture, concrete gutter. So number two, it's got no habitat. It's got no riparian vegetation. There's nothing living in a concrete gutter. Instead of having nice consistent temperatures, number three, a canal has extreme temperature spikes. At night, it gets colder than a river because it's got no insulation. And in the day, it gets hotter because it's got nothing but direct sunlight. Extreme temperature spikes. And number four, in a canal, you get stagnant water. Nothing breaks the surface, so there's no dissolved oxygen. Thank you, he is here. Diego, do you want this? No. Shall I highlight for you that a no-show will result in SAT detention?
Yeah, I guess like one of those per period.
I was just trying to be a bro and highlight for you. Yes. Sorry, no, I'm back to the physical realities of a canal now. I've switched from the river to the canal. So, that's right. You get stagnant water with no oxygen in a canal. So I don't know if you understand, but ecologically, what I've just said is a pretty good setup, right? No habitat diversity, no riparian vegetation, extreme temperature spikes and no dissolved oxygen and stagnant water. That's going to say pretty obviously there's no ecological function in the canal. A canal is just trash water. It's just a toilet. It's just a way to flush water. You get rid of turds. The canal has no ecological functionality. It's a dead non-river. Yeah?
Do you get any groundwater recharge from the canal?
No, so when you talk about human benefits, number one, instead of bioremediation, you get a flush of pollution. Number two, instead of groundwater recharge, you get flooding downriver. They're impermeable. They're made out of concrete. So instead of storing groundwater under the river, you flush all your nasty pollution to whoever's at the other end of the canal. And then number three, what kind of recreational value is there in a concrete gutter? I mean, maybe you can skate it. Maybe. Probably get busted for that. Yeah.
Couldn't you turn part of the canal into a bioswale? And
so the 2014 version is bioswales leading into canals that have islands of habitat. Anybody want to ask me anything about channelization? Yeah.
So are canals and channels do they have very little benefits or?
There's only one benefit to canals. Nobody likes dealing with flooding. By the way, if you wanted to start your cities from scratch, you would just build a little further back from the wetland and get all the ecological benefits, plus the recreation, plus the food, plus the clean water, plus the groundwater. You just don't put houses where the wetland is. And then you have to worry about the flooding. What's up, T-Bone?
Hello, sir.
Nice to see you.
Good to see you too.
Gabriele no está today.
That's a sad thing.
It is. I miss your mustache.
You know, I was kind of like, what am I?
I mean, you're handsome enough as it is.
It's kind of fun, but like stuff was getting stuck in it. I have more of a hiding issue maybe than you do. I'm not sure.
This is true. Okay. Hi, T-Bone.
Hi, bud. If a river ran through a city,
Yes, if a river ran through a city.
would all those ecological benefits and all that diversity and everything just diminish, and then it would literally turn into a
So, you can avoid this. You can avoid this. Look, back in the day, people thought of the river on a very short timeline of water capacity. So, like, this is kind of an elevator. Half the kids are going to fall asleep, so I'm going to try to rush this. Historically, the river is the place where the water is. You build right up to it because you need water and a place to dump your garbage. So in city design, 1800s, you just build right up to the water. And then, oh my God, we're flooding! How could this possibly happen? The river's supposed to stay put. It's just a very narrow-minded definition of what the river does. Provides you with water, it takes away your trash, and it stays put. By 2014, we know all this ecological stuff, and flood cycles, and irrigation, and blah, blah, blah. You could do it again today. You would just have what's called a riparian buffer. You would build up to like a mile up from the wetlands. And then you'd have this giant green belt. Play space, farmland, parks, recreational activities. And then you would bioswale to filter all your runoff before it hits the river. You get all those ecological benefits, the diversity, the recharge of your groundwater supply so that your city has a greater supply of clean drinking water. But you got to trade off some of that dirt. Like no nice riverfront housing. You know, you can't build the office building with like spitting off the balcony to the river. Like that's nice, but you can't do that anymore. You know, the trade-off would be we should now start thinking of the river as this living, breathing ecosystem with fuzzy borders that accommodate for the 50-year flood or whatever. It's not rocket science. Like, seriously, if we knew all the environmental science we know today, like 200 years ago, and we made city planners have like a scientist on board, like we could shrink environmental science problems down to like almost nothing. If only, right? Yeah, or not. Okay. 24 was fun. That was channelization. What?
So channelization is just kind of how we channelize our water through canals.
Yes.
Wait, is it a fire or a flame?
So is water science science in water? Alright! Now everybody, excuse me, back to me. Hairy guy in the front. That'd be me. Watch this. What does biodegradable mean?
Biodegradation.
Yes, break that down. It's got 3 parts. Bio, degrade, able. What does that mean?
Degradation of of a biological substance.
Yes, a substance that can be broken down by living things. Can be broken down by living things. Biodegradable. Can be broken down by living things. When I finish eating my apple, I throw my apple core out the window. When I finish eating my banana, I take the little Chiquita sticker, I put it on my cell phone, and then I throw my banana peel. My wife goes, "Stop it, you're polluting, nobody wants to see that." And I'm like, I don't care what humans think, it's mouse food. I like mouses.
Mice.
Oh, really? Thanks. We don't really think of biodegradable stuff as garbage. I mean, compared to the plastic wrapper, the almond is not really trash. Plastic wrapper will last like 15,000 years or something. Almond will last like 10 minutes and then a rat will eat it. Biodegradable stuff in particular, we just never think of it as trash. But there is a sense in which it's a very serious water pollutant. A very serious one of the most serious ones. Because all that stuff that the canal is carrying, that should have just been recycled into a Happy Creek ecosystem, it is a very serious pollutant. Watch this. When you have biodegradable waste, and by biodegradable waste I mean sewage, food, agricultural waste, slaughter waste, lumber mill or paper mill waste, and urban runoff, this is like industrial scale. We're talking city volumes, not like Andrew Fay's apple core. But like all of Santa Barbara's apple cores, plus banana peels, plus dog poo, plus bum piss, plus grass clippings, plus whatever. City volumes enter the river. When you look at that, you think, oh, no big deal. That's just going to, feed some bacteria, and then that's going to become algae, that's going to become insect, that's going to become fish. And the answer is, yeah, we're cool. But let's start with that bacteria. Watch me. There's always some bacteria in the rivers. Because, like fishies poo-poo, there's always going to be a little bit of bacterial activity. And there's always a little bit of oxygen entering the water. As the surface of the water moves, especially in a natural river where it moves a lot, oxygen dissolves into the water and CO2 is released to the air. So there's always a little bit of oxygen coming in, and there's always a little bit of bacteria eating fish poo and stuff. Yeah?
The CO2 that's leaving is from, the fish breathing?
Breathing and stuff.
Like biodegradation.
That too. But now, here comes the problem. When you make a large urban contribution of biodegradable waste, decomposition levels will spike. And that means oxygen will quickly run out. Immediately where decomposition begins, you see a sharp decline in oxygen levels, until you reach what's called the dead zone or septic zone of the river. There is an oxygen sag. Because of all that decomposition before, the oxygen's been used up. Nothing lives here, no fish. Just decomposers like insect larvae, leeches, worms. You get this layer of sludge on the bottom. Any fish that gets trapped will likely die. And when I say no oxygen, you should remember something we talked about before about anaerobic versus aerobic. Anaerobic is like, you know, your gut. So you know what thrives in here? Poo-poo bacteria thrives in here. This looks a whole lot like Jose's colon in here. It's anaerobic. There's like partially decomposed sludge. Dead fish. Guess what I had for dinner last night? Welcome to Jose's colon. The septic zone. So your poopy bacteria love this part of the river. Now remember, as the water flows downriver, it interacts with the atmosphere and oxygen is dissolving. So gradually oxygen levels come up. As decomposition levels go back to normal base levels, those nutrients get soaked up and cycled into biomass. Fishies are happy again. And then when you step back from the river, look what you'll find. A clean zone with happy fishes, lots of oxygen, just base level decomposition. The decomposition zone, where you get a couple of tough fishies, oxygen levels are declining rapidly because decomposition is spiking right where you have all that biodegradable material coming in. The septic or dead zone, which has no oxygen. Nothing can live there except for those anaerobic decomposers like the ones in your dookie. As oxygen is added by the water's movement, you get the zone of recovery, a couple of tough fish, decomposition levels are back to pretty low, oxygen levels are rising, and then where oxygen is at normal level, they could oil that. Where oxygen levels are back to normal, and decomposition is back to normal, you get another clean zone, happy fishies again. Everybody wins. So here comes a news flash for you. Jose lives in the mountains every summer. I have proof. And for the last 15 years of my life, where I spend my summers at high elevation, I drink natural water. I drink wild water. You're not supposed to do that. Don't do what I do. You could die. But I drink wild water every single day I'm in the Sierras. It's like a practice for me. I kiss the earth. I don't even use a cup. I just go drink up the river. But you know what? I do not drink the still parts. Because if there's not a lot of oxygen being added, the dookie bacteria are loving it. That's not what I'm looking to drink, thank you. I have children, I don't need any more poo in my life. The place where I like to drink the water is where dissolved oxygen is high, like the bottom of a waterfall. Right after a big class 5 rapid, a big riffle, a lot of oxygenation, bubbles. Right where the white ends and you get nice clear water, that is what I drink. It is my communion with the Creator, so to speak. I love drinking my wild water. I go glug, 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 and then I lay out on a hot slab and I take a nap and I get sunburned. Yeah.
At a certain elevation, you know you need to like filter water.
I do not own a water filter.
Do you filter water when you're at a lower elevation?
I would if I were. But I live in the subalpine during the summers. So usually I'm like an hour, 2 hours walk from snow. So up there, there's very little introduction of organic material. There's not a lot of poo in the water. With the water being so young, so cold, so ultraviolet dosed, and so oxygenated, It's pretty darn clean. It would be a really different story if I was at low elevations where the water's been meandering for a few days. Not so much. Yes?
Have you ever gotten sick from drinking it?
Nope. Okay. Can anybody imagine, since oxygen is required to recharge the water, can anybody imagine why the Santa Barbara wastewater treatment facility is the largest user of electricity in the city?
That'll move all the water.
From hills, go up the mountain, flood north.
No, it's not because we move the water. The water moves because of gravity. What? Why they use so much electricity?
Classic.
You be quiet. Just sit there. Why do they need so much electricity? To oxygenate the water. They have these giant air pumps. You ever seen an aquarium? Those little air stones at the bottom? They go. When you go to the wastewater treatment facility with me next Monday, you'll see there's these pools that are like the size of this classroom. And they have these air stones that are the size of a manhole cover. And they make like giant columns of air bubbles. Like hundreds of them in each pool. To provide oxygen, because oxygen is what's required to fuel the decomposition. It's the only thing they have to add to your water. Do you know that? To do your wastewater treatment, there's nothing added. It's the bacteria that came in your turds, the ingredients that came out of your drains, and the only thing that they add is oxygen to help those bacteria do their thing. Yeah, bro?
Wouldn't there still be a lot of stuff left over that's like inorganic?
There's not a ton of inorganics in our waste stream. So the main inorganics is the medications. So like all the Xanax and Oxycontin or whatever. I don't know what the hell they said. Birth control. I know that birth control makes it. Hormones.
So that's what this goes through the
Pretty much, yeah. Yeah, it's very difficult to get that out. And there's heavy metals from our food supply. So we eat a lot of seafood in Santa Barbara, and so it's basically all concentrating all that biomagnification into a small place. A lot of heavy metals in there. But almost everything else is organic. I mean, think of like what you wash off your body, and it's like chemicals that you use on your body, which are usually relatively organic.
like shampoos and stuff?
Relatively. Like that stuff breaks down. Hydrogen, phosphorus, potassium. All right. Anybody else want to talk about this? Because I got a little story to tell you. There's this little country called
Canada.
And it's actually the United States. All right. So we have this one giant watershed called the Mississippi. Look at what's included in the Mississippi watershed. Everything to the left of the Appalachians, to the south of the lakes, including some of the lakes, stretching into Canada, and everything to the right of the Continental Divide. All this goes into the Gulf of Mexico via the Mississippi. That's a lot of real estate. Now, does anybody know when is the best time to go get an ear infection at the pit?
After spring, man.
After which rain in particular?
First rain.
First rain. Because in Santa Barbara, on average, you get April, May, June, July, August, September, into October, right around 6 months of dry. That's 6 months of dog crap, college deviant barf, bum piss, fertilizers and pesticides from home gardening and whatnot, Jose's apple cores and banana peels, dead birds and whatever. 6 months of that just sitting around Santa Barbara, baking in the sun, rotting in the marine layer, and then it's like first rain, it's like washing off the driveway after 6 months. And all that stuff just goes the pit. And it's like, oh, it's the first storm, there's waves! And you get out there and it's like, oh, my ears are bleeding. Now imagine what it must be like instead of just the Arroyo Burro watershed. Look at this watershed. I wonder if there's any small source of pollution in this area. Like Kentucky. I mean, there's like so much stuff. Like huge cities. My brother just got a job in Cincinnati. Oh my God. I mean, it's like, you name a big city in the United States, chances are it's in the Mississippi watershed. Sorry, I gotta answer this phone. It's gonna totally ruin my day.
What about Los Angeles?
Now it's gonna crush my timing.
This is Jose.
Crap. Definitely not today. I still don't know about tomorrow, and I got a lecture. I'm sorry, but it's not today. What? I'm sorry. I'll write a note right now. No problem. No problem.
Sorry about that interruption. I'm sorry, I only have 5 minutes and I really want to use them. Imagine all of the sources of stuff here. Imagine how much stuff has decomposed into basic ingredients. Nitrogen, phosphorus, and potassium. Remember, he asked me about shampoo and stuff? And I'm like, yeah, no big deal. That breaks down. Everything breaks down, you know. All of the shampoo of this area, plus all of the soap, plus all of the bum piss and dog crap, it's all broken down. You know, it's biodegradable. It has biodegraded. But when that Mississippi River dumps all those nutrients into the Gulf of Mexico, you can get too much of a good thing. You see, nutrients are good. Nutrients equal life. We need nutrients. Nutrients make you beautiful and perfect as you are. But number 28, there's this thing called eutrophication. 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 E-U-T-R-O. P-H-I-cation. Where you get too much of a good thing, too many nutrients. Anybody know what the problem is with having too many nutrients? Well, yeah, but
Clogging of depositional.
let's be really clear. The bad part is not too many nutrients. It's that eventually they're going to run out, and then everything dies off, and when everything's dead, it decomposes, and then oxygen, and then you get a dead zone. Anybody know what is the worst thing about a really great party?
The cleanup.
The cleanup! So, yeah, right! He does know. So watch. All those nutrients come into the Gulf of Mexico, and when you flood the Gulf of Mexico with nutrients, guess what? The algae goes, "Woo, party!" And algae populations explode. And then all the insects go, "Woo, party!" And they eat all the algae. And then the little fish go, ew, party. And they eat all the insects, and then the big fish come by and they go, hooray. And they eat all the little fish. And you know, when you add a bunch of nutrients to an ecosystem, usually you just get this burst of productivity in life, and that's not bad. It's literally like the most glorious moment in life of the ocean. The flip side is that there's a decline in nutrient levels. So at first you expand the food web, and the food web swells from the bottom, and then as it constricts, all that dead stuff, biodegradable oxygen sac, dead zone.
Doesn't that happen naturally?
Kind of. And so there are these like natural rhythms where this is like a thing that happens naturally, for sure. When we add more nutrients to land, you're going to get more eutrophication and a growing dead zone. So you can actually show the size and duration of dead zones growing as a direct proportion of agricultural output in the American middle. As our agricultural yield goes down, like in a drought year, the size of a dead zone will start to shrink because there's less organic material added to land. So the dead zone has less death, and so it shrinks and it goes away faster. Have any of you heard that you're not supposed to eat shellfish in months that end with an R? People say don't eat oysters and mussels October, November, December. That's exactly why. Because in the first floods of rain, you get all these nutrients that everything takes off. And it's a party, and everybody gets excited. And you know the good stuff grows, but so does the bad stuff. And so your filter feeders, like oysters and mussels and stuff, they soak up a lot of the good stuff, and they also soak up some of those toxic bacteria. And when you eat mussels in November, well, they're going to be kind of bad for you because they've got all the good stuff, and they've got extra volumes of the bad stuff. Shellfish closures, part of the natural cycle.